Dear students, in the previous class, we have discussed second colligative property, that was elevation and boiling point, and today we are discussing the third colligative property, that is depression and freezing point. Now, what is freezing point? It is the temperature at which solid and liquid state coexist. Now again, if we plot a graph between vapor pressure and temperature, then for a pure solvent, we will get a curve like this. And this is the freezing point of the pure solvent. This will be the freezing point of the pure solvent. Here it will be in the solid state and here it will be in the liquid state. So this is the point at which both the states will coexist. So this is the freezing point of pure solvent. That's why we will denote it as TF naught. Now, on adding the non-volatile solute, what will be the curve? The curve will be like this. And here this point will be the TF, that is for freezing point of the solution on adding the non-volatile solute. Now, as you are seeing that here there is depression, or you can say there is decrease in the freezing point. On adding the non-volatile solute. So here this difference between TF and TF naught will be denoted as delta TF. Now we can write down that what is TF naught? TF naught is the freezing point. It is the freezing point of pure solvent. And what is TF? TF is the freezing point. It is the freezing point of solution. And what is delta TF? It is the difference. Between here TF naught minus TF. Now mathematically we can write it down as delta TF directly proportional to molality small m. So on putting the value of small m, or by removing the proportionality constant first, we can write it down this as delta TF is equals to KF into m. Here this KF is the molal depression constant, or cryoscopic constant. And here delta TF will be, on putting the value of molality, it will be KF into WB into 1000 divided by MB into WA. So this is the formula for depression in freezing point, and as it is depending upon the number of moles of solute particles, that's why this is a colligative property. Now, where we can find these type of solution which depresses the freezing point of any solution? So first is antifreeze solution. These are the solutions which lowers the freezing point of any solution on adding the non-volatile solute. For example, ethylene glycol and glycerol. These solutions are when added, then the freezing point of any solution gets lowered. And the second is NaCl and water. This NaCl here acts as a non-volatile solute, and on adding it will decrease or depresses the freezing point of water. For example, it is used in making ice creams and kulfi, and it is also used in laboratories to lower the temperature up to minus 33 degrees centigrade. So these are the applications of depression and freezing points.